And hello there, folks. This is your Uncle Troy. Today we're talking about Maze Wars. I actually have some audio to go with this visual presentation, and if you just tuned in to watch the pretty colors slide across the screen, then feel free to mute this commentary and go about your business. I won't be the least bit offended. This is kind of an afterthought anyway, but I thought I would talk about some of the technical stuff behind the program that is creating the pretty pictures you're looking at right now. Back about 1982, 3, 4, something like that, when I had my first computer, an old Texas Instruments TI-99 4A. I think it had 16 kilobytes of RAM. It ran at like 1 or 2 megahertz, which means the smartphone you're using to watch this video is many times more powerful than that first computer. But we had a maze generating algorithm that I picked up out of some magazine, because back in the old days that's what you did. You didn't have the internet, you didn't even have FidoNet, you didn't have bulletin board systems you could call up on your modem. You didn't even have modems back then. So what would happen was you'd buy magazines and type in program listings from the magazines to create the programs you used, or you'd create your own once you got a little better at it. So I found a program that created and solved mazes. I think it was called Amazing, A-maze-ing, amazing. But the point was it used very little memory, very little processing power, but it could create mazes. And so, of course, I typed it in and ran it, and it didn't work right because either there was something wrong with the program or I typed it in wrong, which both were very common things to happen back in those days. So I made some changes to it to get it running. It never ran right, but I remember the basic principles behind the program, and so every so often I would rewrite the program on whatever computer and programming language I was using at the time to have it generate and solve mazes. And so it's actually a pretty simple program once you figure it out. Basically what you do is you define 4 directions: up, down, left, right, north, south, east, west, whatever you want to call them. But if you pick direction 1, it's always 1 space up, 0 spaces left to right. Direction 2 is always 1 space to the left, 0 spaces up, down, that sort of thing. You define the 4 cardinal directions, and then to generate the maze, you hollow out a random start point, and then you pick a random direction. You roll the dice, generate a random number, whatever you want to call it, and then you check, is there an open space there, or have you moved there before? And you say no. Okay, fine. Then you carve out a path in that direction. And important thing, you set down a breadcrumb or draw a little arrow saying I came from direction number 1 to get here. That's important for later. So then you roll the die, create a random whatever, and it says move in direction 2. So you say, have I moved over to that spot before? No. So you move. Now eventually you're going to randomly choose a direction that leads you to a place you've already hollowed out. So in that case you ignore that and just pick the next direction. And so you move around, but eventually you're going to catch yourself in a corner. You're going to get yourself into a dead end where there is no way to move without hitting a place you've already hollowed out. So that's when the breadcrumbs come in handy. So you look down and you say, okay, I got here by following direction 1. So I just move the opposite of direction 1, and I move back 1 space to a place I've already been, but which may have an opening that I can use. And this is called a DFS, depth first search, where basically you go as far as you can into the data until you hit a dead end, and then you back out just far enough to find a new direction to go in. So that's what you do. And then when you backtrack all the way back to your starting point, then you're finished. So that's what I did. And so you can create mazes with it, but you can also solve mazes with it by just looking for places you haven't visited before and keep going around until you find the exit. And as I discovered with the Color Wars program that you've already seen pictures of or videos of on this channel, you can also use it to fill in colored areas, because that's all a flood fill basically is a search algorithm looking for open areas that haven't been filled in yet. So you search, fill in, and then if you paint yourself into a corner, you back out until you find an open area and start filling again. So the Color Wars basically did that, and the maze program basically did that as well, just different algorithms. So this program combines the mazes with the color fill to create what I think are some interesting effects. So what it did was it picked about 16 different colors, about 16 different starting points, and about random links, legs, whatever you want to call it, of the search. So in some cases it just looks at the pixel next to it. Some cases it looks at the pixel 4, 8, 16 spaces away, which is why you have different sized mazes. And so you can draw out a large maze with big steps, and then a smaller maze can fill in inside the steps, which is what happens in these things. So we're starting a fresh one here. You see one of them has some huge steps, and then the others have smaller ones. So inside and around the huge steps of the maze is smaller steps, and then the ones that are tiny fill in the cracks in between. So you end up filling the whole screen full of color eventually. As you can see, this is the smaller the steps, the longer it takes to fill it in. But it's all filled in, and then it goes blank, and then it starts again. And in this case, all the steps are fairly small, so you don't have those huge things, but you do see that some are larger than others, and then the smaller ones fill in. And this is, like I said, it's a depth first search, which for small mazes works pretty good. For larger mazes, sometimes it doesn't work so good because you end up with very long paths without many branches, I guess is what you're going to say, because it tries to fill in as much as it can. So you end up throwing in some variables like, okay, you know, if you've gone 10 spaces without a branch, throw in an unnecessary branch just to make it more interesting. Sorry, I get distracted just watching these. But you can see that it kind of fills in everything. Each of the I got 16 colors running at once. Actually, 16 colors running one after the other, but they're all operating on the same screen, so they, interact with each other. But each one has a different starting point. Each one has a different step value, and the directions. Each one has a different set of directions. So for color 1, direction 1 is up. For color 2, direction 1 might be down, or left, right, north, south, east, west, etc. So that with the same set of random numbers have different behaviors. For example, you got this one here that's kind of just circling the perimeter, filling in from the outside in. That's because its particular set of directions, if it can't move in one direction, it picks another direction, then it picks another direction, and those directions just happen to be, first look up. If you can't move up, move left. If you can't move left, move down. If you can't move down, move right. And that works together to make kind of a circle. There you got a couple that are going around and around, and others that are just kind of randomly filling in. And so the interaction of them is what makes it interesting. Of course, it's random. And you say, oh, I liked, the image at 9 minutes, 20 seconds in. Can you recreate that for me so I can blow it up and make a poster out of it and whatnot? And I'm like, no, I can't, because every one of these is a combination of random numbers. And so random, no two are ever going to be exactly the same. They're all going to be unique, and you can never go back and find one again, which is fine with me. But if somebody said, well, I want a high resolution version of this one, can you recreate it for me? The answer is no, I can't recreate it for you. Deep, watching this. Sorry, had to take a drink there, but like I said, I just, when I'm creating these, I just sit here and kind of watch them. And I've always meant to figure out how to make an official screensaver. Technically, you can take the executable file that creates these things and rename it as a SCR and put it in the right directory, and Windows will treat it like a screensaver. It doesn't always work properly, but it is possible. So somebody with more understanding than I have about how Windows screensavers works wants to turn this into a screensaver, I'll be happy to give you the source file and all the information that's necessary to turn this into all the information about how this program works, so you can turn it into a screensaver if you want to. This is programmed in a program language called GFA BASIC 32. It was created by a guy named Frank Ostrowski for GFA BASIC Limited Inc. or something. Anyway, the company name has GFA in it, and some funny letters, which basically means manufacturing concern in German or something like that. Anyway, so Frank Ostrowski was a retired military officer back in the 80s, and he didn't like some of the things going on with Atari BASIC back in the old Atari 8-bit days. Just didn't like some of the things that Atari BASIC did. So he started rewriting some of the routines to work better, a little faster, more logical, etc. And eventually he ended up rewriting so many of the routines that he thought, why am I bothering just patching BASIC? Why don't I just start from scratch and write a basic programming language for the Ataris that makes sense? And so he created something called a Turbo Basic XL, because the Atari XL line of computers had just came out. And it worked pretty good. It had a primitive compiler / linker. It created programs that ran much faster. The programming language had several commands that BASIC or plain old Atari BASIC didn't have, and it worked great. And then later, when Atari came out with the ST line, Atari ST line 16/32, because it had a 16-bit processor and 32-bit address lines, or the other way around, I forget. But anyway, the Atari ST came out. He wrote GFA BASIC for the Atari ST, and that was also ported to the Amiga and MS-DOS and possibly some other systems. And then later the company came out with GFA BASIC 16, which was for early 16-bit Windows, Windows 95, 98, Millennium Edition, that sort of thing. And then they brought out GFA BASIC 32 for the 32-bit operating systems, Windows XP, and so on. And so if you learned to program back in the early days of Atari, and you stumbled across Turbo Basic XL and started programming on it, then moving from Turbo Basic XL to GFA Basic for the Atari ST when you bought one was pretty easy. And then when you moved from the Atari ST to a real computer, quote unquote, such as, you know, an early Windows machine, then moving from GFA Basic for the ST to GFA Basic 16 for MS-DOS or early Windows was easy step, because it was the programming language written by the same guy. So that's how I ended up here in 2016 programming GFA Basic 32, is because it reminds me of GFA Basic for the Atari ST, which reminded me of Turbo Basic for the old Atari 8-bit computers. I used to have a Atari 130XE, by the way. So because I am familiar with the programming syntax, the logic that the Frank Ostrowski used when he was deciding, how program commands should work and whatnot, I know how Frank worked, so I know how to program his language here. So I stumbled across GFA BASIC 32 a year or two back, which was odd because it's been out since like 2000. Whenever Windows XP came out, that was about the last time they updated GFA BASIC 32 for Windows. The company that makes the program has gone out of business. Who actually owns the copyright to the program, nobody's really sure. So some fans have taken upon themselves to decompile the program and fix some little bugs and recompile it so it works with newer operating systems, etc. So any day now, the FBI might raid me to shut me down because I'm using a programming language which is, owned by somebody else, and I didn't pay for it. But I would happily pay a reasonable amount of money for this program if somebody, could come up and say, we officially own the rights to this program. Here's where you buy the newest version, which is made for Windows whatever. I almost said Windows 7 because that's what I use, but, Microsoft has since gone to Windows 8 and Windows 10, and by the time you watch this video, there might be a Windows 11 for all I know. And I was quite happy that I wrote programs which I know for sure run in Windows 7, and then I was on the internet the other day and somebody, casually mentioned, somebody had said something about Windows 7, and they said, well, why are you bothering supporting a obsolete operating system that's been discontinued by its manufacturer? And I realized, they're right. Windows 7 probably isn't even supported anymore by Microsoft. They're probably just putting out virus definition updates and critical things, if that. But as far as I'm concerned, Windows 7 is superior to Windows 8. And what little I've seen of Windows 10, I don't really care for. Windows 7 is kind of sleek, small, does what I need it without a lot of extra flash, kind of like Windows XP. I'm not a big Vista hater because I was using Windows 2000 and Windows XP when Vista came out, and I didn't update immediately. So by the time I got around to using Vista, they had patched most of the problems and had gotten it working pretty good. So I stayed with Vista for a long time before I tried 7 because it worked for me. And to be honest, the difference between Vista 7, 8, and 10 are not very great. In fact, internally, it's like, Windows Vista is like 6.0, Windows 7 is like 6.1, Windows 8 is like 6.2, and now Windows 10 is like 6.4 or something. It's not a major change. It's mostly it's a difference in the programming interface, a difference in how it looks to the end user, not so much difference under the hood how it works. Basically, you're taking the same 350 V8 with a 4-barrel carb and taking it from a Chevy and putting it into a Ford, but it's still the same engine. It still works the same way. Anyway, so and finished. So as you can see, it's going back to what we started. It's creating little mazes with different lengths of wall, and then the smaller mazes are filling in between the big mazes, if that makes any sense. And in some cases you get solid fields of color, and in some cases you just get multiple little, smaller and smaller. But it just fascinates me the way the little lines run around and fill things in. And so that's why I like watching this. And I generated a lot more images than I needed for this 20-minute video, just because I like sitting here and watching them fill in. Incidentally, how the video is created is the GFA BASIC program saves bitmap files. That's a built-in command every 50 milliseconds or so. So you get about 25 frames a second. Then I use FFmpeg to come by and turn all the bitmaps into a MP4 file, which then I use another program to edit together to put them all together for this video. Running out of time, so Uncle Troy signing out. Please have a good night.